Good morning, guys. We're going to do another lesson here. This is in chapter 13. We're obviously running out of time. We're not going to be able to finish all chapter 13, so I'm going to pick what I think is the most important, try to get through whatever lessons we can. So chapter 13, first lesson we're going to skip. It's on definition of locus. The third lesson has to do with locus intersections of loci, and we're not going to do that. So 12-13-2 on page 702 is what we're going to do, okay? So we're talking about locus and systems of linear equations. So what you might want to do is read through those pages, look at those examples, because I'm not going to do those examples, and then come back to the video, okay? So this is systems of linear equations, and homework number 15 will be number 12 through 30. That will not be due until May the 11th, all right? So plenty of time to get this done. I assume you're pausing, get this written down, I'm going to erase it. So we talk about systems of equations. Basically, a linear equation makes a line. Another linear equation makes a line, okay? If the lines are parallel, they never intercept, then there is no solution. In other words, there is no point that satisfies both equations. That's what we're looking for. You could tell no solution if you end up with something like 5 equals 13. Well, 5 does not equal 13. So obviously that's not true algebraically. If you're doing it graphically, graph is a little tricky. You graph a couple of equations and they might look like they're parallel, but maybe 25 miles down the road, they actually run into each other. So that's a little tricky. You would have to actually calculate slope on both and make sure the slope is actually the same. So that's possible. Another possibility is that we have one equation, the other equation actually is exactly the same equation, lies on top of it. That's called infinite solutions, okay? Or the y equals mx plus b, the equation of the line is a solution. So that's possible as well. What we're looking for, though, in our case, what we're looking for is for it to turn out that one line intercepts the other line, okay? All right, and so on the assignment then problem number 12 through 17 says graph each pair of equations and find the locus of points that satisfy the graphs of both equations. So that's what we're looking for. So you have to do a separate graph for each one of these problems because that's 2 lines already. You got to show me your method. I do not care if you use the point slope method, show me rise or run. I don't care if you use XY chart with these 3 points. I don't care if you use the intercepts method. You have to show me, though, on your paper what method you use to graph each line. So it's a fair amount of work. I understand that, but you've got over a week to get this done, okay? All right. So once you solve it, you're going to find out what is actually an approximate point. Even if we did this on a graphing calculator, it would still be an approximate point, some x and y value. So in order to make sure that is correct, what I need to see on your paper is you plug in the answer you got from the graph into both equations and make sure it works for both equations. And then you know that's the answer. So that's almost half the assignment. And again, it's going to take a while, but please do not blow this off, okay? It's not going to help your grade, all right? So that's one method for solving a system of equations. So we do that for a couple reasons. First off, really, if you're good at graphing is a quick way of coming up with an estimated answer, which is sometimes all you need is an estimate. Even the graphing calculator only gives you an estimate. Also, graphing demonstrates to you that maybe that's not the way you want to do it. So there's several other ways besides graphing. 2 algebraic methods we're going to talk about, which you learned about in algebra because the law of substitution, or the substitution method, the elimination method, both of which we have used throughout the year a couple of times, primarily the substitution method. We've used those before. In matrix algebra, we have something called the Kramer's rule, which if we had more time, we talk about, but we don't, so we're not. And there are other methods, but we're going to look at 2 algebraic methods, substitution method and elimination method. So if you want to, you can stop the video now and do all your graphing. When all your graphing is done, then you can come back and finish the lesson. So for 18 through 29, it says use either substitution or elimination to find the locus of points that satisfy the graphs of both equations. All right, so I'm going to do about 3 of these for you. The rest you're on your own, okay? So we'll do number 18. So we're going to do the substitution method first. All right, so this is number 18. And we have x plus 2y equals 10. And we have y equals x minus 4. All right, substitution method works really, really well when you've got either y equals or x equals or a equals or something, okay? Because if I've got y equals, that means right here where I see y and here where I see y, I can substitute x minus 4 for y. So that would give me x plus 2, y equals 10, and in place of y, I'm going to put x minus 4, okay? And then now I just solve the equation. So I've got x, I distribute, that's x plus 2x minus 8 equals 10, all right? And now I'm going to combine like terms, x plus 2x is 3x. And I'm going to add 8 to both sides, which gives me 3x equals 18. And then divide both sides by 3, and that gives me x equals 6. And then once I have my x, I'm going to go back and substitute. Y equals x minus 4, y equals 2, okay? So to check it, I go to the other equation, okay? And in place of x, I'm going to put 6. And in place of y, I'm going to put 2. So 2 times y is 4, and 6 plus 4 is 10. That checks. So my answer is 6 and 2. You always write your answer as an ordered pair, because what you've done is you're showing if I graph this line, this is where they would cross, okay? That's the whole point of the substitution method. All right, and you can easily do the substitution method. Again, that works on number 19, number 20, 21, 22, 23. You can also do that on 28 and 29. They both have either x equals or y equals. Let me point out one thing. On number 22, you have y, this is 22, you have y equals x minus 1, and you have y equals 6. Well, if you got y equals and y equals, then that means this has to equal this. So x minus 1 equals 6. Solve for x. You already have y, so that's pretty simple. So don't get disturbed by y equals y equals. If you have y equals on both of them, then the other side is equal to the other side, okay? If I have a equals b and a equals c, then obviously b equals c, okay? All right. All right, let's look at the other method, okay? The other method is called the elimination method. Okay, elimination method. So elimination method is really not necessarily easier, but sometimes it's difficult to do the substitution method. Look at number 24. 24, I've got 3x minus y equals 11, and I've got x plus y equals 5. All right, I could actually easily solve for x or solve for y and do the substitution method. You can do that, but if you choose to do that, you need to show me your work. And that's okay when you have nothing in front of an x or y. But if I had like 3x minus 4y equals 11 and 5x plus 6y equals whatever, then obviously that would be difficult to do. You'd end up with a lot of fractions, and I'm sure you don't want to do that. So elimination method basically says if a equals b and c equals d, then obviously a plus c equals b plus d. So I can just add. 3x plus x is 4x. Y minus y cancels. Y is eliminated. 11 plus 5 equals 16. Divide by 4. And x equals 4. Okay? And again, this works because I have something that's the opposite. If they're the opposite, they're eliminated. And then once I have x, I'm always going to use the substitution method for the second term. So in this case, x is 4 plus y equals 5. Subtract 4 from both sides gives me y equals 1. If I check, 3 times 4 is 12. Minus 1, sure enough, is 11. So my answer is 4 and 1, okay? All right, I'll do one more of these for you. And remember, you can always pause while I'm erasing and get it written down, what you need to get written down before you move on. All right, let's look at, I'll look at 25. X minus 4y equals 9, and 2x minus 3y equals 8. All right, in this case, x and 2x are not opposites, negative 4y and negative 3y are not opposites. So I need to have these numbers the same or these numbers the same, and then one plus and one minus. So I'm going to multiply either one or both to get that. Well, I've got a 2x, so if I multiply the top equation by negative 2, then negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8y. And negative 2 times 9 is negative 18. The big mistake that most students make is forgetting to multiply all the way across. And then now I have a 2x minus 2x, and now the x's are eliminated. 8 minus 3 is 5y. Negative 18 plus 8 is negative 10. Divide by 5. That gives me y equals negative 2, okay? And then again, substitute x minus 4 times negative 2 equals 9. A negative times a negative is a positive. Subtract 8 from both sides gives me x equals 1, okay? 2 times 1 is 2. Negative 3 times negative 2 is plus 6. 2 plus 6 is 8. That checks, so my answer is 1 and negative 2, okay? All right, again, get that written down, pause. However you want to do that. We'll talk about 30 and then we'll be done. This time, what you guys don't know is this is the second time I've done the lesson this morning. I started the first lesson, recorded it, and the recording went off, and I did the whole lesson, and it wasn't recorded, so I have to do it over again. All right, that's okay. I fixed some mistakes. All right, number 30 says the graphs of y equals 3, x, y equals 7, y equals 2x, and y equals 2x minus 13 intersect to form a parallelogram. So you're going to graph this, okay? You get a separate graph paper again. Y equals 3 and y equals 7 are both horizontal lines, okay? So they're obviously parallel. Y equals 2x, y equals 2x minus 13 are diagonal lines, but they both have a slope of 2, so they're parallel. So you draw your two horizontal lines. You use whatever method, X, Y chart, whatever, to graph your two equations, but you got to show me how. And then you graph it, and it says find the coordinates of the vertices. So you just write down all 4 intersections, which are ordered pair. That's part A. Part B says find the area of the parallelogram. Well, you have horizontal lines, so you can count. That's going to be like the base. And then you go perpendicular to that, which is a vertical line, count your spaces. That's your height. Multiply those two together to get your area. And C says find the locus of points that satisfy the graphs of all 4 equations. I'll let you play with that. So you're looking for a point that is on all 4 equations. Should be logical to you. All right, that ends the lesson. So there I am. Okay. Later, enjoy.